Welcome back to another session on continuous learning. Okay,
Yes.
so today we will cover an important topic in the world of machine learning and NLP, that is vector embeddings. Okay, so this is important because this is kind of the base of what the machine learning and NLP does in the background. So it is important that we know what are embeddings, what is a vector, and how things are represented in the vector world. Okay, so I will share my screen. Um, Able to see my screen?
Yes.
Yes.
Okay. So it's a simple definition of vector embeddings. So vector embeddings are extremely powerful tool in natural language processing, as they can enable computers to understand natural language text in a way that is similar to how humans understand it. Okay, for example, let's say we are asking a question to any chatbot or chat GPT or anything. So what it does is it is actually taking your text as an input, and it is going back and it is trying to find a similar or corresponding documents from its knowledge base.
Promise പറഞ്ഞ 3:30 വരലുണ്ടെങ്കിൽ വിളിക്കണം ഞാൻ വിളിച്ചില്ല.
Okay. So so it is actually looking for the text or the document that corresponds to your input search, and it is in few minutes, in few seconds, it is able to find relevant documentation. And then what it does is it comes back, it comprehends the information available on the document it searched and took, and what you have asked, and it is giving you a relevant response. Okay, what is happening in the background is, so they, people would have trained these models with large amount of data, right? So when you say large amount of data, it is a lot of documents, documents from the web, documents from print media, documents from wherever you have information available. So that is called a corpus. So that corpus is actually converted into something called vector embeddings. Okay, so what it means is, if you take one particular a sentence, that sentence has many things to comprehend, right? As a human, you can understand. If you say he is a boy, you can understand that we are talking about somebody, because we say he. We can say that it's a boy or a girl. We can comprehend. So how we are doing that is, we are connecting that with our defined knowledge of many things. We correlate a lot of things, and we determine, okay, this is the meaning that we are trying to convey in the sentence. So how neural networks or the natural language processing tools understand that is, for each of the word and each of the you know text available, they call it tokens. Okay, so token is nothing but simply, you can say a small word. Okay, for each of the word, they take and create relationship between many different parameters. So for example, there are a lot of parameters that you will consider, and you will see what is relationship for this word against that parameter. For example, when we say a boy, that is, if you take a parameter called man, that is closely related. If you take another parameter called woman, a boy and woman are, you know inversely related, right? So the similarity between these two are different. So that is, that's a different, between these two words, it's a different parameter. So like that, they will actually rank for each of the parameters that you're taking against the word, and that is what is going to say as a vector. Let's say if you are taking 1,000 parameters and applying that to a particular word, and say, okay, out of these 1,000 words, 100 words are closely related to this word, all the other are not closely related. So you will rank them from 1 to any number. So that is what a vector is. One word translates to 1,000 different representations and relationship between 1,000 different words. So that is called a vector. So if we do this for every word in that text, then you get a large vector. By let's say you get a large vector of numbers. Practically, it is all floating numbers. Okay, so that is what a vector is. So when you want to search with a text with the available corpus, what it will do is it will actually take your text, it will embed it, and it will search against the already embedded text. Okay, and it will try to find the similarity, and that's how you will get the responses. Okay, a small example here. So you can see here, man, woman, boy, girl, and if you apply these three parameters or factors to see a man, what is the similarity for the femininity? Nothing. Youth, royalty, nothing. So woman, if you take woman and femininity are closely related, so you rank it. And boy is, yes, you boy can be a youth. So this way you will actually form a vector, a matrix, right? So this is what is going to feed or going to be your uh, search data rather than the actual word itself. Because if you try to search words in a large corpus, you may not be able to find that, okay, a boy can be also be represented as a youth. You may not be able to find. You will just be searching boy in your large corpus, and you may find text only that corresponds to boy. You may not know youth is also closely related to boy, and any sentence that talks about a youth is also related to a boy, right? So that kind of representation will not happen if you don't have this kind of vectorized data. So this is what is vector embedding is, and there are a lot of tools available in the market. Every NLP model or anything machine learning model provides its own tool for generating the vector embeddings. If you take OpenAI, it provides its own model for embedding that will come with around 1516 vectors, 1516 by 1516 vector representation for each of the text you throw at it. Okay, that is called vector embedding. And this shows how it is actually embedded. So you give whatever you want as an input, and you will have an embedding model. And it can be, if it's audio, it can be an audio model. If it is text, it can be a text model. If it is a video, it can be a video model. And everything at the end, it all comes out as series of floating point numbers. So it depends on the model, on what is the dimension of your vector is going to be. So that depends on the model, and that depends on how you create the model. Okay, it varies between model to model. So you just give any object that will throw you out a floating point number of vectors. So that is what is actually stored, and that is what is actually related. Or what they do is they take the text that you are giving, and they will again give it through the model, take the embedding of that, and it will browse through all the embeddings that is already available. So it will find a match between the embeddings. So that is called similarity, semantic similarity search. So it will be able to find all the embeddings that are very similar, and for those embeddings you will already know what is the actual text. So you will take the text. Finally, you will have some set of paragraphs or sentences that are closely related to what you are asking, and that is what is fed to the chat gpt or any chat bot that is going to respond. So any you know chat model or any chat application that needs to respond to you, chatbot that needs to respond to you, it needs to know what you're asking. It needs to know the corresponding relevant document to refer. So that relevant document is what is going to come out after you search through the embeddings, with the similarity search and all. So that's what does vector embedding is. And if, any process involves this is the first step. You will first get your corpus, you will create embeddings for your corpus, then on your application you will embed the text that you are asking, and then compare it and get the output. And you can enrich it by adding more and more dimensions to it, or adding more and more data to it. So that will all, as you keep enriching your vector embeddings, your results will be accurate. So here is a example. Okay, so if you ask a chatbot, okay, who won the Super Bowl last year? So to answer this question, the chatbot first needs to understand what is Super Bowl, right? Then it needs to know what is, winning the Super Bowl means, and when actually, the last year was. So because you are just asking who won the Super Bowl last year, right? So it needs to take these things and it needs to comprehend, understand this, and then give you the result. So in the vector space, you will see similar words and phrases having similar embeddings. So the chatbot can use a similarity between the embeddings of Super Bowl and NFL Championship. These two are same. So if we just search for Super Bowl, we may not get anything referred to NFL Championship. So but if you are embedding, it will already be matching. The numbers will be matching for both Super Bowl and NFL. They will be very near to each other, and it will pick it up to know that it is the same thing. So it can also use a similarity between the embeddings of won and victory. In some sentences, it may just say victory, victorious, or anything, right? And they are synonymous. And the last year means it should know that okay, it has to be 2022. Then that is how it will select all the related or closely related documents. Uh, then give you the right answer. So using these vector embeddings, the chatbot can accurately answer the question by searching corpus for relevant information and using embeddings to understand the meaning of the text. So that's what is happening. And so how it is enriched? You can enrich it by adding more information like domain specific knowledge, more context to your data by adding more dimensions to it. Um, so it depends on the model that you are building. So usually any model that is built, it will be generic, but if you want to enrich your results, then you can fine tune your model to your domain specific knowledge, and with that if you create the embeddings, it will be even more accurate. So that's all about vector embeddings for today, and it is mainly used in the space of natural language processing and machine learning. So
Thank you, Prem. Is
that's
there any questions, team?
So Prem, before NLP came into existence, chatbots were connected to intents, right? You have to
mhm,
define an intent, and that was more like fixed set of intents on the chatbot can only answer that.
correct,
So NLP was introduced, so you don't have to pre-program the intents, right?
correct, correct.
Okay, okay. Is there any market service for this, or you have to write your own models? Is there any
No,
managed service?
there are many, every machine learning model that you take, a machine learning library you take, that will have a function
And
for embedding.
okay,
So OpenAI also provides one. So you just pass your text, you say how you want to embed. There are some few parameters that you have to just specify, and it will embed it for you and give you.
okay.
And you just have, and that brings up a different aspect to how you store the data. That's another important point. So it is not like normal data. It's also you can consider it as normal data, but it is not like searching for the normal data, right? You have to search what is inside the embedding to find the similarity.
Mm,
So that is a different aspect to storing the database and searching. So nowadays there are many SaaS applications emerging that will host the vector data as their database, and they will help you find the similarities between your text and the actual embedding, your corpus embedding. So uh, uh, even in chat gpt models, where you are actually if you are going to have some plugins added and all, you are going to use that vector database where you can store your own data's embeddings, and you can find the similar text from that.
okay.